as you may have guessed by the screen on in front of you, that I'm talking about encrypting active record models tonight. My name's Dan Draper, if you hadn't already guessed that, and I'm the founder at CipherStash. And yes, I have been through the funding journey a bit lately, so if anyone would like to talk to me about that, I'm more than happy to do a talk on that. But tonight I'm talking about data security stuff. So first question you might want to ask is, why should I even consider encrypting my active record models? What am I getting from this? I'm going to start on some sort of high level stats kind of stuff, and then we'll talk about the more technical reasons. But number one, these to me are absolutely mind-boggling stats. 1 in 2 US companies suffered a breach in the last 3 years. It's according to Forbes. And if they were a healthcare company, only 1 out of 10 did not have a data breach. So 90% of healthcare organizations had a data breach in the last 3 years, which is, to me, that's absolutely terrifying. And on another another way to look at it, according to a report in IBM, by IBM last year, they release a report on this stuff every year, so there should be a new one soon. Every single one of the records that were breached on average cost $180. That's in impact on business, notification costs, cleanup costs, fines. There's all kinds of things that they look at. But has a big impact on businesses. So you might be asking yourself, well, what about encryption at rest? I'm already encrypting my data. I go into, I'm using Amazon RDS, I'm using Postgres or something, and I go and check the box, add a KMS key, and we're cool, right? Well, encryption at rest is good, but let's sort of unpack what that's actually doing. So when we're encrypting, when we say we're encrypting our data at rest, what we're actually talking about is the file storage or the file system. And in the context of a database, that Postgres or MySQL or MongoDB or whatever it is will run on top of that server with that encrypted file system underneath it. Now, this protects us from the case where somebody walks into a data center, yanks out a hard drive, and tries to read the contents from that drive in a Amazon Web Services or something. I don't even know where the data center is, and good luck guessing which of the gazillions of racks your particular drive is in. Not to say that we shouldn't protect it like that, but it's protecting us from a different class of attack. In a cloud connected world, encryption at rest actually doesn't protect us from very much at all, because in order for a database to run, as soon as you boot the database, everything's running in the clear. All the data, all the queries, everything is running in plain text. And on top of that, the actual key needed to decrypt the data has to live on the same machine. So if that machine is compromised, or if somebody gets access to it that they're not supposed to, or a backup goes missing, or what have you, you're still in quite a lot of trouble. And so some of the threats that we might think about, even though we're using encryption at rest, SQL injection. It's the oldest trick in the book when it comes to attacking applications. It doesn't protect you from that. A leaked database dump. Somebody's got a Postgres dump of the database up in an S3 bucket. That doesn't protect you from that. Database creds. If you're using Postgres, for example, you've probably got one connection string in your Rails app, and it's the same connection string that everybody uses in production. If that is leaked, then whoever gets access to that gets access to everything. Another one that we sometimes don't think about is unauthorized access. So this is maybe internal staff that have access to the database because they need to do maintenance on it or check migration status or something. We don't necessarily want them to be able to see the actual data that's stored in the database. So that's encryption at rest doesn't protect us from that. And of course, the obvious one is if an attacker gets access to our database. And note that that's the one that I mentioned last, because sometimes people say to me, well, my database is not likely to get attacked. I beg to differ, but I wanted to point out the other ones first before we start to argue about that one. So really, what we should be thinking about, and this is really the crux of this talk, is the idea of application level encryption. So rather than talking about encryption at rest, you can think of this almost like encryption in use. So you've got encryption in transit, encryption at rest, and this is encryption in use. And so that would look something like that. If you've got a Rails app that's connecting to a database, whatever that may be, and now the encryption is actually taking place in the Rails app itself before the data even gets sent to the database. You'd probably still want to have encryption at rest as well, just as a backup option. But now the actual records in your table are encrypted, and the database never sees any keys and never sees any plain text data. So this pretty dramatically changes the security of a system. And there are two major options for ActiveRecord. Actually, there's quite a lot more, but these are sort of the two that I would say are the best options available. There's several of the others have been around for a while, and these are really quite good. So Lockbox, that's available for Rails 6 and 7, and recently with the release of Rails 7, you can actually use Rails encryption in ActiveRecord directly. So it's part of Rails 7 now, which is really cool. So if you're using ActiveRecord 7, Rails 7 and ActiveRecord encryption, you would do something like this. So if you've got an email field and a name field, you would literally just call the encrypts method as a sort of a DSL method inside your user model, presuming you want to encrypt the fields in your user model, and that would allow you to perform encryption on those fields. And it's transparent inside the Rails app. So if you're you want to create a user, pass a name and an email, that will actually get encrypted. But when you retrieve it, it's automatically decrypted. So to the end user, you don't really notice any difference, at least as far as this is concerned. We'll talk about some of the limitations in a moment. And in the database, it looks something like this. So if I pop into Postgres and I select email from users, the email now actually looks something like this. So I won't break down this in detail now. Maybe that's a subject for another talk, but suffice to say that's using very strong encryption. If you've got an existing app and you want to add encryption to it, that's relatively easy to do as well. You just need to specify this config option. So you're going to say the ActiveRecord encryption support unencrypted data equals true. So that means that you're essentially running your database or your table for the model in mixed mode for the time it takes for you to turn on encryption or to encrypt everything. So if I want to encrypt an individual record, I can find, say, the one with ID equals 1, call encrypt, and that will automatically encrypt the data, all of the fields that I've specified using that encrypt method, and save it to the database. So similarly, if I wanted to do it for all of the users in my database, I can just use the find each method and iterate through all of them. Depending on how much data you have, that might take some time, but it's not too expensive. If you want to encrypt non-text types, though, things like date of birth, or dates or timestamps, integers, those kinds of things, there's a little bit more of a consideration that you have to make. So when you encrypt any value, it pops it out in a text or binary form. So everything that gets stored in the database is always going to be text. And that isn't necessarily sensible. If it's fine if you've got name and email because they're just strings. But if you've got a non-string type, like a date of birth as a date, you need to work out how to serialize or convert those types. Now, sadly, ActiveRecord doesn't do a very good job of that yet. There are some kind of clunky workarounds, but really, if you want to handle non-string types, I'd still recommend going for Lockbox. So Lockbox has got quite a nice little DSL to specify the types that you want in the plain text side of things inside your model. It uses now, instead of encrypts, it uses Lockbox encrypts. It's slightly confusing because in Rails 6, Lockbox called it encrypts. Then Rails 7 came out and called it encrypts. And so in Rails 7, Lockbox now calls it Lockbox encrypts, just so that it doesn't clash. So, that just makes it super clear. But in any case, what Lockbox allows you to do is specify the type, and these are all the different types that it supports. So if you've got non-string types that you want to encrypt, Lockbox is probably going to make it a bit easier for you. So then the next question you might ask is, what should you encrypt? What sort of data in my application should I encrypt? I would say generally you don't need to encrypt everything. I probably wouldn't bother encrypting everything because not everything is sensitive, and it does add some overhead. So what are some of the things that you might want to think about? The obvious one is PII, or personally identifying information. And that's typically things like name, email, date of birth, maybe phone number, those kinds of things. And in some cases, an IP address, if you're able to tie the IP address back to an individual, those kinds of fields can also be considered PII. Side note, PII and these definitions are also sometimes the subject of legislation and regulations. So you think about privacy principles in Australia, or GDPR or HIPAA or CCPA, these sort of different regulations. Some of them have slightly different definitions, but for the general case, that's what we mean by PII. Another example is PHI, or protected health information. So if you're working in healthcare, insurance, or some sort of adjacent industry, you probably want to be thinking about these. According to HIPAA, which is the US healthcare standard, there are 18 items on the PHI list, and they include things like name, email, date of birth, height, weight. I mean, in the US, it'd be social security number, but generally any healthcare identifier that you want to think about there. So should we encrypt financial transactions? And I might actually throw to the audience. Does anyone want to weigh in on whether we should encrypt financial transactions? Take it from your silence, no one knows, or no one wants to put their hand up.
Does it depend on whether you need to be audited or something?
Yeah, I mean, that's a good point. It can depend on what industry you're in and what regulations you might have to comply with. Different parts of the world have got different requirements there. The consumer data right, which is part of open banking in Australia, doesn't actually mandate that you encrypt data, but that is the case in the EU, for example. So it depends on where you're operating. But generally speaking, if we're ignoring the compliance lens for a moment and just looking at the security lens, one interesting fact is that only 3 transactions for a person are required to uniquely identify an individual. So that is to say, if you know that they bought a Mars bar from the Coles Express, I don't know, a burger at McDonald's, and a train ticket at Wynyard Station, then there's a very high likelihood that you can identify that exact individual. And so if you're thinking about this idea of PII, personally identifiable information, if you know enough information about the individual, this sort of data can actually be considered PII as well. So it's something to be conscious of. So let me ask you another question. What about location data? So like tracking longs and lats and things like that.
Encrypt.
Any thoughts? I would argue encrypt. I mean, so obviously I'm biased. I'm kind of advocating pretty hard for encryption here, but it's the same thing. If you're tracking location data, say longs and lats, same mathematical principles apply, and only about 3 points are required to uniquely identify an individual to about 90% confidence. So once again, it depends on your threat model, depends on how concerned you are about this data or what compliance and regulation you might need to comply with. But I obviously advocate for encrypting that if you can. Next thing you want to think about when encrypting anything is key management. Your security is only as good as access to the key. You could have a Fort Knox building, but if an attacker has gotten access to the key and can let themselves in, it's sort of all for nothing. So there's 2 main ways that you can approach it. The simplest way, slightly, it comes with some security trade-offs, which we can talk about perhaps after the session if anyone's interested. But the easiest way to get started is just using 3 keys with ActiveRecord encryption and 1 key with lockbox. You can put those in your Rails credentials or an environment variable, and that's a reasonable solution. It's certainly significantly better than not using application level encryption at all. The preferred way, or the better way, and in my view, and for lots of reasons, is to use something like Amazon's key management service, KMS. And this provides you with what's called a CMK, customer master key, and an external key provider. And so this is using a technique called envelope encryption, which means that in order for an attacker to compromise your data, if your keys are stored in the Rails app directly, then they would still need to be able to obviously compromise your Rails app. But if they compromise your Rails app, they would maybe also now be able to decrypt data. Whereas with something like KMS, they would now need to compromise both the Rails app and the key management service, or some vector into the key management service, in order to be able to decrypt everything. So it's really, none of this stuff is foolproof, but it's really providing you with just more kind of protection. But think of this sort of stuff as like 2FA for your email system. Password plus 2FA is still not unbreakable, but significantly better than one or the other. And as point of reference, the guy that wrote Lockbox, Andrew Kane, has also written a gem called KMS Encrypted, which allows you to hook into KMS to do that with Lockbox. Right, so I'm going to show you a demo. This is where ActiveRecord encryption and lockbox and any kind of ALE or application level encryption has a couple of little issues. So I've got I've called it a playground here. Can everyone see my terminal, by the way? Yep. I've seen a few nods.
Can you
Cool.
enhance, Stan, make that a bit bigger?
Oh yeah, of course. Yep.
That's great, thank you.
That's good. Cool. So let's do a really simple query. If I wanted to do a search for a user, say by their, in my example here, I'm using first name and last name instead of just name. But if I wanted to look up, there's a user that I have in the database, so someone called Dallas. It's all from fake, so they're weird names. I want to look up that user. I'm not going to get any results back. And that's because what it's trying to do is compare the encrypted query to encrypted data. So there's no sensible way to do that, and so it doesn't know how to return the query. Another example that we sometimes people forget when they're starting to implement encryption is if we wanted to order by string. It's a very common thing. We want to order by first name in a report or a list or something like that. I'm going to go first name, just so that it's really obvious. I go select first name and say limit get the first 20, something like that. And you can see that the query still works, but the ordering doesn't make any sense at all. They're all totally out of order. And that's because what ActiveRecord's actually doing is ordering by the underlying encrypted values, not by the plaintext values. And because they're all fully randomized, there's no sensible ordering that makes sense for a human. And in fact, if you were to encrypt these values again, the ordering would be different again. So ordering is completely broken when we turn on application level encryption. So how do we solve that problem? There's two main ways. I'm going to give you a third sort of bonus option at the end, but I'll focus on these first two for the moment. So the first one is this idea of deterministic encryption. So that means that every time you encrypt a value, instead of being fully randomized, it's always giving you the same result. So the same input always gives you the same output with a given key. And you can specify that in ActiveRecord encryption, for example, using the deterministic true option, which I've done for email in this case. And so that means if I've got deterministic encryption enabled, this kind of query will work. So I can look up somebody based on their email address. Now, there's some problems with this. Deterministic encryption is fundamentally weaker than standard randomized encryption. And one way to think of that is if you've got, say, a table with some deterministically encrypted data in it. So I've got an email, ciphertext, and the product name. Realize these are around the wrong way. Kind of crappy example, but you get the idea. And I wanted to see those values. You can see here that even though the email is encrypted, I can see that whoever bought pizza also bought chocolate. So we've now actually learned something about the data set. And there's some really clever mathematics and some clever tools that you can, if you're so inclined, you can probably download off the internet. Not suggesting that you do that, of course, but you can use the fact that there's determinism there and statistical analysis to actually break the data. And you can determine a lot of the information. There's some papers from a few years ago that showed that for certain classes of data, you can reveal up to 90% of the data just by the fact that it was deterministically encrypted. And to show that in a really simple way, this is sort of a visualization of what randomized versus deterministic encryption looks like. So obviously you've got your original image on the left-hand side, and this is fully randomized encryption. It's totally unintelligible. Tux has completely disappeared. But when we're using deterministic mode, sometimes called ECB mode or electronic codebook mode, this is still pretty visible. Like our eyes can look at that. Like it's not quite Tux anymore, but we can still see that it's a penguin. And that's sort of a rough analogy of what's actually happening when we've got deterministic encryption. But there are more problems with deterministic encryption. These kinds of queries, like if I wanted to do email like some substring, or if I wanted to order, it still doesn't solve the ordering problem, or a range query, these queries are not possible. So deterministic encryption, not only is it less secure, but it doesn't actually solve a lot of the problems, a lot of the kinds of queries that we might want to run. So option 2 is a linear search. And this is really just a fancy way of saying, in order to find the record that we want for a given query, I'm going to go to the first record in my database. I'm going to decrypt it. I'm going to check to see if it's the one I want. No. Okay, I'm going to go to the second record of my database, decrypt it, see if it's the one I want. No. And I'm going to keep doing that till I find the one I want. Now, if you've only got 500 records in your database, that's probably fine. You can get away with that. If you've got 5 million records in your database, that's going to become a major problem for you. So linear search, you can totally do it, but let me show you what that looks like. I've done some performance benchmarks here. This is performance benchmarks on inserting 100,000 records just from a fake data set into a database, and then using the different kinds of encryption to sort of ascertain how performant it is. So if I want to insert all of the records, if I'm doing that on it was on my Linux box, and I haven't got any encryption, it takes about 260 seconds. Using encrypted record in ActiveRecord in Rails 7, it's about 308 seconds, and Lockbox pretty similar. So insertion speed is actually not too bad. If I wanted to query all those records back out again, so just load them all out in one big hit, it only takes 3 seconds. If it's plain text, you do get a bit of a hit when you're decrypting them all. So obviously it's quite a bit slower, but still, 20 seconds to load 100,000 records is not too bad. Now we're starting to see some big hits in performance. So finding a single record, say based on that email address, with Rails 7 encrypted record, 257 times slower. So you're going from 7 milliseconds to 1.8 seconds. Lockbox, even worse, 414 times slower. It actually is worse if you try to find a record that doesn't exist, because obviously then in the linear case, you're going to have to go through all the records in the database before you know definitively that that one doesn't exist. So that's even slower, 771 times. And then I've also created two other benchmarks. These are like the this kind of query. So doing an email match, like a like query, and it matches lots of data. So the plain text is really fast. But when you're doing it in an encrypted database, it's abysmally slow. The worst case is when you don't match anything. You have to go through the entire database before you know that you haven't matched anything. And with Lockbox in Rails 6, it takes 5.3 seconds with 100,000 records. It doesn't sound like that much. But if you think about it, if you're on a user interface, mobile app or a web app, and you're typing in a query, it takes you 5 seconds for a single response. That's pretty terrible. And note also that this is it has linear performance. So if it's 1 million records, it's going to be 10 times that amount of time, which would be about 50 seconds. So you're basically waiting for a whole minute in order to find a record if you've got a reasonable sized data set, if you're using this kind of approach. So that's a problem as well. So I would go so far as saying at this stage that if you're using ActiveRecord encryption or Lockbox, you should do so if you are able to retrieve records by their ID, and you don't necessarily need to do any kind of complex queries. However, this is my shameless plug, so I'm sorry about that. But this is option 3. This is what we're building at SafeStash. So we've created this gem called ActiveStash. And essentially what you can do is you can you install the gem, include this ActiveStash search, encrypt the data as you normally do, and now you're specifying these indexes. So we're specifying that we want to be able to do queries on name, email, and date of birth. We're also specifying this thing called stash match all, which allows us to do free text search across both name and email at the same time. So now, even though my data is encrypted, I can do things like this. So I can do a user query where I can look up an email address. We haven't overloaded where. We've got a new method called query. There's a bunch of reasons behind that. If anyone wants to ask me why, I'm happy to talk. If I want to do free text search across name and email, I just pass the string. I can do sorting, similar to how I would have done it before, but with this query chain. And I can do range queries. So I can do date of birth more than 35 years ago, so anyone that's over 35. I can do complex queries by using a block, good old Ruby for a block. And I can also chain with active relation. So it still ultimately looks a bit like ActiveRecord under the hood. And the way that works is this thing called the look-aside pattern. So if you've used Elasticsearch in a Rails app with something like SearchKick, you might be familiar with this sort of pattern. But now instead of Elasticsearch, we're using SafeStash, which is a fully encrypted search index. So that means that your data in your database is encrypted using Lockbox or ActiveRecord. And now SafeStash is also fully encrypted with the key that is managed either inside your application or in KMS, so that SafeStash never sees the data. We don't know what exactly it is that anyone is querying. And so then that has a pretty big impact on performance. You know, we're still not down to that 7 milliseconds, but the point now is that it is nonlinear, it's sublinear. So if you're doing a find, it's 47 milliseconds. Even the worst case, which was previously 32,000 times slower, is only 16 milliseconds now. So that's still quite reasonable for practical applications. And that scales sublinearly. So for 100,000 records, it's not going to be, sorry, for 1 million records, it's not going to be 160 milliseconds. It's probably going to be about 20. So that's kind of how we approach it. I will do a quick demo before I share some parting thoughts. So recall that we actually, I think I might even have, no, sorry, I don't. I was going to show you an example of the linear search, which is, we might be waiting a while, so I won't try and code it anyway. But let's say I want to do a query in CipherStash. So I just want to do a query like that. The first time you run the query, it has to do a key exchange. So it takes a few seconds. This is actually using KMS. The next time you run it, super snappy. You can do things like order by first name, and I'll do the same sort of thing I did before, so it's really obvious. So you can see that they're obviously ordered. And once again, this is all encrypted, so you can't see what's going on under the hood. I can chain things. I can do things like, let's go Q. Yeah, B more than, say, 30 years ago. And I want to order by B, and then limit 10 will do, and then runs a query like normal. So the DSL's a little bit different, but essentially you get to keep all the functionality that that you previously had before you did the encryption, and yet simultaneously, this is what your database actually looks like. It's fully encrypted. So you're kind of meeting those security goals. This meets a whole bunch of different requirements for different compliance and legislation. The cool thing is you don't have to compromise on performance or queryability. So some parting thoughts. There's no such thing as perfect security. It sounds like an obvious statement, but you'd be amazed at how many people have said to us, we don't want to encrypt because there's some you know, possible attack vector remaining. Well, you know, you should still try to block as many holes as possible, even though there might still be some threats. You can think about this in terms of like a reduced surface area, and the analogy is, you know, an old castle, medieval castle. They would fortify the whole of the, you know, the surrounds of the castle walls, but they'd have to have some way to get in and out of the castle, and so they'd put all of their soldiers and their weapons by that gate, and so that means that they've got a reduced surface area of attack. So only an enemy is only likely going to be able to attack that area, and the same is true in cybersecurity. And finally, please consider encrypting your data. Even if you're only encrypting some fields, it's better than none. And the fact that it's built into ActiveRecord now is hopefully starting to make it significantly easier for people to do that. So if you want some more info, I've created a little page on our website here, cypherstash.com/Roro, which has got all the links to the repos, source code, and some documentation for things like KMS. If you want to have a look at ActiveStash, I've linked that as well, cypherstash.com/ActiveStash. And if you want to stay in touch, feel free to follow me on Twitter @DanielDraper. So yeah, that's it. Apologies for the shameless plug, but I hope that was useful and interesting to people, and happy to answer any questions that you may have.
Great, that was fantastic. Thanks, Dan. You heard it here first, folks. Encrypt your stuff. All right. Anyway, does anyone have any questions for Dan?
I have a question, but I'm not sure if it's a dumb question. But
No such thing as a dumb question.
So how does it do non-deterministic encryption if it only has one key?
Yeah, that's a great question. I'll give you the really short answer, but there's a much longer answer. So we're basically using this technology that came out of Stanford. It was a culmination of years of research and a paper that was published in 2016 called Order Revealing Encryption. It's some really interesting, clever technology. Took me a while to understand that. I actually went and did some further study. I did a graduate course in cryptography at Stanford. And mathematical cleverness, without going into more detail, it's hard for me to explain it, but essentially they've come up with a really clever way to encrypt data in a randomized, non-deterministic way that can still provide for range queries, and then we've extended it to things like pretext match as well.
But I mean, so when Rails goes to like decrypt the encrypted field from the database, and it's been non-deterministically encrypted, how does it decrypt it?
Yeah. So let me show you. So there's a few things to unpack here. One thing that's probably worth pointing out, if I do a query, if I scroll up, you'll actually see what's happening behind the scenes. Let me do a simpler one first. Image 5, it's going on. Oops, 50, that'll do. I'll scroll. So what this is actually doing, this is ActiveStash is essentially intercepting the query, encrypting the query, sending that to a CipherStash collection, which is using this order revealing encryption technology to determine which records match. It doesn't know anything about those records, but it knows which records match. So then what it does is it sends back the IDs of all the records that match. And then we just use a simple ActiveRecord query. So select star from users where users stash ID in that list of records. And then we just rely on the built-in ActiveRecord encryption in this case to decrypt the actual data. So CipherStash doesn't actually store the actual data. It's just like a one-way index.
Yeah.
Sorry. Go ahead. Sorry. Maybe that wasn't
if you're not using CipherStash at all, if you're just using like Lockbox or the Rails encryption, you're saying that it can do non-deterministic encryption.
Yeah.
But then how does it?
Go on. Sorry.
Yeah. Sorry. How does it decrypt the data if it can go one input string and one key produces many encrypted outputs, and then it can get back to the original one?
Yeah. So sorry, I misunderstood your question. I get excited about CipherStash, so I went straight to CipherStash. Sorry about that. This is sort of part of standard randomized encryption, and the way that it does it is using what's called an initialization vector. So every single time you go to encrypt, you've got one key, but it generates a cryptographically secure random number. So that's really just a way of saying a very hard to guess random number. And then it's essentially, you can think of it a little bit like a salt, sort of analogous to a salt. And then we'll use the IV to provide sort of a random input to that encryption. And so every time, even if you had the same value that you want to encrypt many times, you'd have a different IV every time. The IV, although you don't want it to repeat, it's not necessarily secret. So you store the IV along with the data. And so then when you go and decrypt it, you just use that IV to know how to decrypt that particular value.
Yep, that makes a lot of sense. Thank you.
Yeah, no worries.
Can I piggyback on that question, just with regards to non-deterministic encryption? Is there Dan, do you know if there's like a known feature set that I'm guessing you have to give up if you decide you want to use non-deterministic encryption? I'm wagering that you probably won't be able to do like a uniqueness validation, like when a user signs up with their email and stuff like that. Is there anything else that is like that you just have to sort of accept that, like if you're trading a higher security for a reduced feature set?
Yeah, uniqueness is a good example, and ActiveRecord encryption and Lockbox both talk about that. So you could use. The interesting thing about uniqueness, it's actually probably okay in a lot of cases to use deterministic encryption to manage uniqueness. And this is the reason why. Deterministic encryption is not secure when you are able to look at the same value encrypted many times, because then you can do what's called a statistical analysis or an inference attack. But because it's unique, you're guaranteeing uniqueness, there's only ever going to be one copy of it anyway. So if you have a unique field like email address, for example, using deterministic encryption would be totally fine for that use case. You obviously still have all of the challenges with queryability and so forth, but from just like a validation perspective, that's totally fine. Obviously the other things you're giving up, we didn't talk about storage requirements. So there are some increased storage. There's an increased storage overhead in your database. So obviously this is a lot bigger than an email address typically. Now there isn't really a difference between deterministic encryption, at least in the way that Rails does it. But in Lockbox, deterministic encryption is actually smaller than the non-deterministic, the randomized, just because of the particular scheme that it uses. So there are some considerations with the amount of disk space it uses. Ignoring the query stuff, that's probably the only thing I can think of off the top of my head. Yeah. Does that answer your question? I think, was that Paul that asked
Yeah,
that
totally.
question?
Yeah, it was. Yeah, thank you.
Yeah, cool. No worries.
Brandon asks, how does storing the data in the CipherStash index DB encrypted with one key differ from storing the data in Postgres SQL encrypted with one key, not just where the key is stored? It's in the chat if you want to read it.
I will read it. Sorry, I didn't quite follow that.
No, that's fine.
So there's a little bit to unpack there. So CipherStash is using you would actually use a separate key first and foremost, and we use KMS as well. But I think the key is, excuse the pun, is that it's essentially just a different representation of the same data. So if you were to access CipherStash, but not necessarily like an attacker was able to access CipherStash, they got access to the key that's used or credentials or what have you. There'd be a few things that have to do to achieve that. Let's assume they could do it. They wouldn't actually be able to decrypt anything, because all of the encryption scheme that we use in CipherStash is a one-way scheme. So it's not a hash function, but it's a little bit more akin to a hash function where you're taking an input, you're putting it through this function, and then you get an output, but you can't reverse it. Whereas the encryption scheme that's used in ActiveRecord and Lockbox is reversible. So it's a two-way scheme. So which obviously you want to do, because at some point you want to get your data back. So they're quite different approaches to handling the data.
Cool.
I'm not sure if that answers your question, but please tell me.
No, thanks.
Yeah, cool. No worries. Any other questions?
Sorry, just a quick question on CipherStash. So
Sure.
that's not self-hosted. That's like something that the sensitive data gets sent to the company CipherStash to store it. Is that a concern?
Firstly, it is fully managed. Yes, we host it in Amazon Web Services, but it's with. So to answer your second question, is it a concern? I guess it depends on your perspective and who you ask. But I'll say it like this: one of the things that our investors were so excited about with CipherStash is that we don't need to see the data. We can't see the data, in fact, and we can't see the keys. So you compare that to something like Elasticsearch, which is fully hosted, well, not necessarily, but there can be a fully hosted version. Once you're putting data into Elasticsearch, it's not saying that anyone from the company would, but theoretically they could go and see that data. In our case, it's provably impossible to do that. Mathematically not possible. So all we really can see is that there is data there, and if somebody performs a query, that data was returned, but we don't know what that data was. So whether that's a problem for you is, I guess, a topic of discussion and whatever level of risk that you see in your business. But that's our sort of unique value prop, I suppose. Yeah. Cool.
Do you have a bug bounty program?
We don't actually yet, but we're about to launch one. We're planning on launching one very soon. So stay tuned. Come and try and poke some holes. I'd be happy if somebody found some stuff. I also just saw a question. What's your take on transparent data encryption? So TDE is exactly what encryption at rest is. It's just by another name. So that's essentially encrypting the the file system underneath the hood with a key that lives on the same machine. So it's basically the same thing.
With the index stored in a different persistent system, how do you maintain transactional guarantees?
That's a good question. We've done quite a lot of work on that. It's basically comes down to, in a sense, it's the two generals problem. So, theoretically impossible to handle all cases. But we also we treat it like you can think of how the data is stored in the database as a essentially an optimistic save. So you'll always get the data stored in the database, and we essentially favor to always get the data stored in the index. So that means if something doesn't go quite right, if something goes wrong, you may end up with stuff in the index that actually isn't in the database. So that's sort of the worst case scenario. And in those situations, we do have to go back and sort of clean stuff up from time to time. So that's sort of the side you fall on. The alternative is that you do the other way, sort of a pessimistic lock, and that means that you could end up with stuff that's in the database, it's not in the index, and that would be kind of crappy, obviously. So it's sort of which side of that equation do you fall down on, and we've sort of taken that path.
Interesting.
There's a whole bunch of other interesting, curly things we've had to think about there, which probably don't have time to go into, but hopefully that helps.
Fascinating product. Thanks.
No worries. Thank you. Sounds like that's probably everything, but yeah, thanks very much for listening. Appreciate the time.